Okay. Topic 2, electronic structure of atom, periodic table and periodicity. Okay, on week 4. Okay, so we have 10 weeks to go, guys. Okay, stay strong. All right, Bismillahirrahmanirrahim. So these are the content for topic 2. So as you can see, we only have 5 subtopics in topic 2. Okay. All right, so let's start with topic 2.1, subtopic 2.1, the Bohr's model of hydrogen atom. So we have 2 learning objectives for this subtopic. Okay, so make sure that you, once you have completed this subtopic, you should be able to state the postulate of the Bohr's atomic model of hydrogen and state the weaknesses in Bohr's atomic model. Okay. All right, so Bohr's model of hydrogen atom. So Bohr's model of hydrogen atom is the earliest, one of the earliest theory. Okay, one of the earliest theory on atoms. Okay, so Bohr's proposed a planetary model with the theory that electrons revolve around nucleus, like our solar system. Okay, so Bohr proposed this. Bohr developed a hydrogen atom model, okay, explaining how the structure of the atom changes when it undergoes energy transition. Okay, so Bohr's major idea is the energy of the atom was quantized or having definite amount. Quantized means something that has specific ataupun requires a specific amount of energy. Okay, and amount of this energy is related to its electron position. So that is what we call quantized, a specific amount of energy. It cannot be more and it cannot be less. Okay, so Bohr suggested that the electron could only orbit the nucleus in specific orbits or shell with a fixed radius. Okay, so this is also has been proposed by Bohr, saying that the electron is orbiting the nucleus in a specific orbit. So this orbit can also be known as shell. Okay, so like what we have here. So we have the nucleus and then this will be the orbit. Okay, so we have electron orbiting the nucleus. So this was proposed by Bohr. Okay. Oops. Okay, so this is the this was the experiment conducted by Bohr. Okay, when an electric current is passed through a glass tube that contains hydrogen gas, the tube gives off blue light. Okay, the light is passed through a prism and split into 4 narrow bands of bright light. Okay, so we have hydrogen gas in this tube. So we pass through the connect this tube with the electric current. Okay, so this later on, this apa nama tu, what we call that, the tube. Okay, the tube will give off blue light. Okay, through this slit. Kat sini ada celah dekat situ. So dia akan pass through the prisma dekat situ. And then the emission. So this would be the emission lah. So these are the colored light that will be seen. Okay, so we have blue, violet, blue, green, red. So what does this represent? Apa maksud this colored light represent? Okay, all right. So this was conducted by Bohr. This is an explanation of the experiment just now. Okay, so why do we observe colors after we have after we have passed through the electric current through the hydrogen gas tube. Okay, so what actually happened was an electron absorbed energy, an electron of the hydrogen atom, okay, absorb energy. It absorbs energy in the form of photons to get excited to a higher energy level as long as the photon's energy was equal to the energy difference between the initial and final energy levels. Okay, the excited electron would be in a less stable position, so it would quickly emit a photon to relax back to a lower, more stable energy level ground state. Okay, so maybe you can refer to this diagram that we have here. So this is the nucleus. So this is the shell ataupun the orbit that the Bohr mentioned just now. Okay, so this is n is equal to 1. Okay, and then this is n is equal to 2. So the nucleus is at the center of the atom. So this is, for example, this is n1, this is n2, and this is n3. Okay, all right. So initially the electron may have been at the ground state ataupun n is equal to 1. Because why? Because n is equal to 1 is the most stable ataupun has the least energy. Okay, the shell ataupun the orbit has the least energy and it is stable. Okay, so the farther it is from the nucleus ataupun the orbit tu, dia farther from the nucleus, the further it is from the nucleus, the higher the energy will be. Okay, all right. So the electron at the ground state, it will absorb the energy. It will absorb the energy from the electric current just now, and it will get excited. Dia akan excited. Okay, it will be excited to a higher energy level. Okay, it depends. It can be excited from N1 to N2 or N1 to N3, N1 to N4, depending on the amount of energy supply to the electron. Okay, all right. So when it get excited, it will become unstable. Okay, because the energy is very high and it is very, very unstable. So later on, okay, to become stable back, it need to return to its lower position. Okay, so from higher energy to lower energy, okay, in order to do so, it needs to release out the energy in the form of photon. Okay, so the energy release will be emitted in the form of colored light. Okay, in the form of colored light. So kita ada, kalau if the ground state is n is equal to 2, that means kalau dia excited, okay, get excited to n is equal to 3, okay, dia lompat and then dia become unstable and then it jumps down ataupun it returns back to the ground state. Okay, it will emit this wavelength number of light. Okay, same goes to kalau it get excited to n sama dengan 4, okay, when it returns back to the ground state, it will emit this green colored light. Okay, or you can refer it as what we have here. So n is equal to 2, this is n is equal to 3, this is n is equal to 4, 5 and 6. Okay, so if it absorb energy and it gets excited from n is equal to 2, and then it comes down, it returns back to the ground state. Okay, so dia akan release the red colored light. Okay, same goes to if it gets excited to n is equal to 4. Okay, when it return back to its ground state ataupun n is equal to 2, okay, it will release out atau emits the green colored light. Okay, so that is what we call transition. Just now? Energy transition. Okay, this is what we call energy transition. Okay, so in order to be excited and later on to return back to its ground state, it needs specific amount of energy. Okay, so that is what we call quantized. If the amount of energy is not enough, that means it will not be excited to the higher energy level. Okay, so the energy should be enough for the for the electron to be excited to n is equal to 1. Okay, maybe. N is equal to 3, n is equal to 4 will require another amount of energy, another specific amount of energy, and so on. Okay, all right. Okay, so these are the postulates. Just now is like the introduction to Bohr's theory. Okay, so these are the postulates postulated by Bohr's. Okay, so based on Bohr's introduced 3 postulates. Okay, so the first one, he mentioned that the hydrogen atom has only certain energy levels. Okay, so the electron in hydrogen atom revolve around the nucleus in a fixed circular orbits that has certain energy level. So this is what we call quantized. Okay, quantized. So it has a certain energy level. It has its own energy. So this fixed circular orbit or energy level is called as stationary because it will not move. The one that moves will be the electron. Okay, so that is why this orbit is called stationary. So this stationary or energy level can be assigned as n is equal to 1, 2, or 3, and so on. Okay, so the higher the energy level, the further the orbit is from the nucleus. Okay, so the higher the energy level, the further the orbit from the nucleus. This is the first postulate. Okay, so the highlight here is the quantized. Okay, and then number 2, the atom does not change energy while the electron move within an orbit. So if the electron move within an orbit, okay, so the atom will have fixed energy. There is no energy change to the atom. Okay, because the electron is only moving within the orbit, not going ataupun get excited to another orbit ataupun energy level. Okay, so this is number 2. This is to highlight the orbit. Okay, the orbit. Number 3, the energy of atom changes. So this is number 2 does not change. Okay, number 3, the energy of atom changes when the electron moves to another orbit only by absorbing or emitting photons. So this is the highlight will be the transition, the energy transition. Okay, so the energy of the photon equals the difference between the 2 levels. Right, so make sure that you know what to highlight, okay, when you are asked in the exam related to Bohr's model. Okay, so this will be your keyword for your for Bohr's postulate. Then from there you're going to expand, okay, based on the keyword. Okay, so this is exactly like what we have in the earlier slide. Yang ni sama je benda ni okay, tapi dia maybe dalam bentuk kronologi lah, chronologically. So this is how hydrogen atoms look like, and then we have electron, okay, at the lowest energy level. So yang the orbit, these 2 is called energy level. Okay, so these 2 orbits, and if we have more, so those are called energy level. So we have nucleus at the center. Okay, all right. So electron in the first orbit, or n is equal to 1, it is closest to the nucleus, and the hydrogen atom is in its lowest energy level, which is called the ground state. Okay, all right. So when this electron is supplied with energy, ataupun the energy is absorbed by the electron. So what actually happened? So the electron now has extra energy. Okay, so it will become excited. So the electron jumps to a higher energy level. So once they absorb, it jumps to a higher energy level. As you can see, this is N1 and this is N2. The dashes line is represent the N2. Okay, so it jumps to a higher energy level. So this is what we call excited state. Okay, so after a while, at excited state, electron is unstable. So the electron returns to the ground state by emitting energy or photon in the form of electromagnetic radiation. Okay, right. So however, there are weaknesses in Bohr's atomic model. Okay, so what are the weaknesses for Bohr's atomic model? Okay. Weakness number 1. Okay, so in total we have 3 weaknesses in Bohr's atomic model. Okay, Bohr could only explain the spectrum of hydrogen or any ions that contain only one electron, such as helium plus or lithium 2 plus. Okay, so Bohr is only limited for atom or ions having one electron. That's the thing. So how about atoms having more than one electron? What would happen? Okay, we know that from the representation just now. Okay, so this is Bohr's model. The electron will jump to a higher energy level, kan? So this is only for one electron. What happens if you have more than one electron? Okay, so when the energy gets absorbed, so is it all the electrons get excited, and then when it jumps down to a lower energy level, okay, how about the energy release? Okay, how is it being measured, and how do we know this energy come from which electron? Okay, so that's the thing about Bohr's atomic model. So it does not cover ataupun cater on atoms or ion having more than one electron. Okay, all right. Number 2, could not predict the energy level and spectra of most atom or ions having more than one electron. This is pretty much the same. Okay, these two lebih kurang sama. So it can only explain for hydrogen, but not for atoms having more than one electron. Because by right, okay, the energy levels and spectra of the energy levels will be more lah. Okay, because it has more than one electron. Number 3, the modern quantum mechanics retains Bohr's concept of discrete energy states. So discrete means quantized, like I said just now, quantized. Okay, it has a specific amount of energy. So at the moment, okay, currently we are using the modern quantum mechanics theory. Okay, or modern quantum mechanics to explain the atomic or the electron properties, okay, and other subatomic particles. So currently we are using that. So that is called modern quantum mechanics model. Okay, so as of now, we still retain the Bohr's concept of discrete energy. Okay, that energy involved during the transition of electron. So we still retain that the energy is quantized, and also during the transition of electron, it emits energy. Okay, it emits energy. So kita still guna pakai. It is still applicable up to this day. Okay, but totally reject the circular orbits he introduced. Okay, totally reject. So this postulate ataupun this proposed theory by Bohr was totally rejected. So electron is not circulating the nucleus in an orbit. No, okay, it's not circulating. Dia bukannya berputar like our solar system. Okay, in fact, we do not know the exact location of electron. If it is an orbit, kalau dia adalah orbit, okay, like our solar system, by right we should know, okay, the location of the electron. For example, we have, katakanlah our solar system kan, kita ada sun, and then this will be the orbit for Earth. Okay, so the Earth will be circulating the sun, for example. Okay, so we have this what we call orbit. So Bumi will be circulating, okay, on this orbit. So the thing about orbit ni, okay, dia akan bergerak. Maksudnya Bumi akan bergerak, okay, this on this orbit. So this is like the pathway. So orbit ni, everything about orbit is known. Dia punya information such as the how far it is, okay, ataupun the distance of the orbit, and then the speed of the and then from there we will be able to know the speed of the Earth, okay, circulating. And then this is by right, dia punya radius should be fixed. Okay, because we know that the electron ataupun the Earth is circulating. But that is not the case for electron. In fact, we cannot say that electron is circulating. Maksudnya dia remain duduk dekat the orbit. No. Okay, no such thing. Because electron cannot be predict. The location of the electron cannot be predict. Maksudnya cannot be, it can be predicted, okay, but it cannot be, it does not represent the actual location of the electron. Okay, it's all about probability. Okay, that's why dia bukan orbit. Orbit, we know everything about orbit. We can predict the speed, the radius, the distance. Okay, so everything about orbit we have that information, but not for electron. So that's why we cannot say that electron is circulating the nucleus in an orbit. Tak boleh kata orbit tu. Okay, right. Okay, question number 1. State the postulate of Bohr's model of hydrogen atom. So based on what you understand, okay, what you have heard from my lecture just now, please not to refer from the slide, okay, based on what you have understood just now. Okay, cuba come out with the postulates of Bohr's model of hydrogen atom. If you are able to do so, that means you punya hearing is very good and you punya understanding is also good. Siapa yang tak tangkap apa pun, silalah refer. Okay, sedar-sedarlah sendiri, ya. Okay, I give you maybe 2 minutes to do that. Okay, so maybe we can have someone to read out his or her answer for this question. Okay, let's have maybe we can have Nur Shahira Saleh. Shahira?
Oh, yes, madam.
All right, okay, Shahira. So what would be your answer for question 1?
The hydrogen atom has only certain energy levels.
Okay, come again.
The hydrogen atom has only certain energy levels.
Okay, all right. So that would be 1 then.
The atom does not change energy while the electron moves within an orbit.
Okay.
The energy of atom changes when the electron moves to another orbit only by absorbing or emitting photon.
Okay, so basically those are the same as what we have in the earlier slide. Okay, so make sure you cater all the three keyword just now. Okay, so go back to the. All right, so this is the three postulates postulated by Bohr. Okay, so the hydrogen atom has only certain energy level. So this is the quantized, ataupun that you can also mention that the energy for the hydrogen atom is quantized. That is also acceptable. Okay, the energy for hydrogen atom is quantized, and by the word has only certain energy level. Okay, and also yes, certain energy levels. So this means quantized. Okay, and then number 2, the atom does not change energy while the electron move within an orbit. Okay, so this is this is to mention that Bohr proposed that the electron move within an orbit. Okay, sebab dia propose yang tu yang kena reject tu. Bohr proposed that electron move within an orbit. So that would be number 2, orbit. Okay, and then the number 3, the energy transition. Okay, the energy transition. So when the electron get excited, okay, to a higher energy level, to another orbit okay, another orbit ataupun energy level, these two carries the same meaning for Bohr's model. Okay, when the electron absorb energy and gets excited, and then later on it will come down ataupun will return back to its original ataupun ground state. Okay, and release energy. Okay, that is also considered as energy transition lah. So anything, okay, you can expand. That's why the what we call the keyword will be quantized, orbit, and energy transition. Then from there you can expand. Okay, sebab nak hafal all of this, dia may take some time lah. Okay, and then nak hafal bulat-bulat kat tu, bagilah. Okay, take the keyword and then from there you expand. Maybe you can use some of the word that has been used in the postulate here. Okay, not a problem, but make it as simpler so that it is friendly to you in order to memorize. At the end of the day, itu je dia punya tu. You bombastic macam mana pun, cara you punya definition ke whatsoever, you boleh ingat tak during exam? Okay? Right. Okay, moving on. Okay, this is what we have here. The hydrogen atom has only certain energy level. The hydrogen atom does not change energy while the electron move within an orbit. Okay, so this is, like I said just now, orbit. Then the hydrogen atom changes energy when absorb energy or emit energy. So this is the transition, energy transition every time. Okay, right. So we are done with 2.1. Next will be 2.2, the quantum mechanical model. Okay, so just now it's like the history part of atom. Okay, and how it is developed from Bohr's theory model. Okay, so Bohr introduced something, okay, that is not entirely wrong. Ada satu part lah yang orbit tu yang salah, that was totally rejected. But the other two, okay, were retained up to today lah. Okay, up to this date. Alright, so next will be the quantum mechanical model. So as of now, okay, we are using this quantum mechanical model. So for this, we have 2 learning objectives. Okay, so make sure that once you have completed this subtopic, you will be able to cross off your checklist. Okay, alright. Okay, this is like a chronology, okay, continuity of Bohr's just now. Okay, so we have Bohr's in the earlier part of the development of atomic model. Okay, next we have the Broglie Postulate. So in 1924, So these scientists introduced the electron's dual properties, the duality of electron, okay, behavior. So de Broglie stated that if light wave can behave like a stream of particles or known as photons, okay, then perhaps particles, which is electron, can possess wave properties. Okay, so electron has dual properties, which is it can behave as particle light and also wave light. Okay, so this is based on the Broglie or de Broglie postulate. And then on a year after, we have Heisenberg. Okay, so Heisenberg proposed the uncertainty principle. Okay, so based on Heisenberg, it is impossible to know exactly both the momentum and the position of any moving particle at the same instant of time. Okay, so electron are always moving. Okay, they always on the move. Maksudnya, if they keep moving, how is it possible for us to locate the electron? So how do we determine the momentum and also the location at the same time? So it's not possible. Okay, kalau kita pun sentiasa bergerak kan, kita always on the move. So it's difficult to cari kita lah, okay, to find us, to locate us or whatsoever. Okay, so that is one of the analogy lah. So anything that is always on the move ataupun always moving, okay, it's very difficult to know exactly the position. Okay, the position to know the momentum and position of any moving particles. Okay, at the same instant of time. So that was highlighted by Heisenberg. Okay, and then later on we have Schrodinger. Okay, so Schrodinger highlighted on the electron position ataupun the coordinates of the electron in atom. Okay, so this was proposed by Schrodinger. So all of these three, dia punya postulates were are still in use, okay, especially for the quantum mechanical model. Okay, dia tak rejected. Dia sebab three of them ni highlighted to different part of the electron. So de Broglie mentioned about the dual properties of electron. Heisenberg mentioned that if the particles is always on the move ataupun moving particle, it's difficult to determine the location and momentum of the particles. Okay, and then Schrodinger later on highlighted on the coordinate, the location, okay, the probability of the electron location. Okay, right. So those three are the most well-known punya scientists lah, theories in quantum mechanical model, the fundamental of quantum mechanical model. Okay, so like de Broglie mentioned just now, the properties of electron. So electron can behave as particle light and also as wave light. Wave light, for example, we have light here. Okay. On the other hand, electron exhibit the properties of light because it can carries energy. Okay, the energy depends on its frequency and intensity. Electrons come in packet or bundles called photons. So we know that electron behave as particle because particle has mass. Okay, and also it has volume. Even though it is the most tiniest particle present in atom, okay, dia tiny tapi it still has mass. Electron still has its own mass. Okay, so dia macam particle lah. Particle kan it has mass and it's consume space. Okay, alright. So those are the characteristic of particle. But it can also behave as wave. Dia boleh behave sebagai wave because dia carries, the electron carries energy. Okay, so that's the thing about electron. Electron because of dia very tiny kan. Dia very tiny. It has the ability to carries energy. Okay, and the energy depends on its frequency and intensity. Electron comes in packet. Dia tak available secara individual normally. Okay, they come in packet or bundles that is known as photon. Okay, alright. So okay, maybe you can refer to this diagram that we have here. Okay, so this is the properties of waves. Nampak tak? Kalau wave, okay, this is in general. Okay, wave has these properties. In which it can be diffracted. Macam cahaya kan, cahaya. It can be diffracted, deflected, reflected. Okay, so those are the characteristic of wave. Okay, katakanlah starting early, okay, as what we have here, dia kat straight line kan. So this would be the original wave. Okay, if this wave, dia pass through the screen having two slits, slit tu celah. Okay, bila dia masuk celah tu, it get diffracted. Nampak tak? Dia diffracted, maksudnya dia diffracted lah. It's no longer the same as what we have earlier, but dia change to something else. Dia punya apa nama tu? Positioning structure dia tu, dia jadi macam it become, okay, earlier on we have straight line kan. Kalau after dia have gone through the slits, they become a little bit rounded. Okay, dia jadi membulat macam tu. So this is how the wave behave. Okay, and then we can detect dia sebagai macam itu. Nampak? So this is wave. Wave in this sense is light lah. Okay, light. Okay, this is particle. So this is how particle behave when it pass through slit. Okay, so we have two slits again. So when this particle pass through the slits, okay, so dia akan terkumpul lah, okay, depending on how many slits that are present there. So if we have two slits, that means dia akan terkumpul sebagai dua collective of particles dekat situ. Okay, so as long as dia boleh able to pass through, that means dia akan bergerak and then retain itself there, okay, dengan kawan-kawannya. So this is the behavior of particles. Okay, cuba tengok elektron. Okay, alright. So electron, okay, nampak tak? This is particle like behavior. Okay, particle like properties or particle like behavior. And as you can see, okay, kenapa dia ada dua slit tapi dia berkumpul tu dia jadi 5. Become 5 groups of electron, for example. Okay, because now dia get diffracted. Dia get diffracted. So bila dia get diffracted, that is the properties of wave. Okay, so as you can see, we have two properties here. Okay, bila dia terkumpul bersama tu, that is what we call particle light. Okay, but bila dia diffracted, okay, even though we have 2 slit, but now they diffracted to 5. Okay, 5 5 parts, that is called diffraction. Okay, so itulah maksudnya. Hope you get that. Okay, checkpoint 2, question 1. State the Broglie hypothesis. Okay, so the Broglie mentioned about the properties of electron. So what will be the properties of electron, guys? Anyone? Hello?
Me, madam. Electron carries energy.
Hypothesis, that would be the that would be dia punya apa, what do we call that? That is the properties of light kan? It's the properties of light. Okay, so exhibit the properties of light. So Broglie mentioned about what? This is what the Broglie the postulate of the Broglie. Okay, so if you are talking about electron carries energy, you are actually catering for the light part, the light behavior, the light properties only. Okay, so it's not complete there. So what should be improvised there? Dia nak kena sebut nama juga awak sendiri.
Have wave-like properties.
Okay, then only that? Is that all?
Have particle-like properties and wave-like properties.
Yes. Okay. So when you are talking the wave-like properties, maksudnya you are only focusing on the wave-like properties. Okay. So that is only part of the de Broglie postulate. Postulate, hypothesis, theories, those are the same thing lah. So what are de Broglie? Dia punya highlight. Okay, so this is a highlight. Electrons dual properties. It can behave as particles and also as wave. Okay, so you kena tahu beza apakah itu statement yang dia explain tu dengan what is the hypothesis ataupun what is the theory itself. Adakah this is the explanation of the theory ataupun the hypothesis itself ataupun dia adalah hypothesis. Okay, so by right this is the hypothesis of de Broglie. Okay, this is the hypothesis of de Broglie. We know that electron, okay, dia highlight, the reason it is highlighted here, electron exhibit the properties of light because electron has particles properties. Tapi dia highlight dekat sini light properties. Kenapa? Because it has these abilities. Okay, so we have to highlight both of them, particle light and wave light. So this will be the de Broglie hypothesis. Okay, so make sure you tahu mana yang sebenarnya the hypothesis itself and explanation kepada hypothesis. So soalan tanya hypothesis ataupun postulate of the de Broglie. So you kena highlight the duality properties of an electron. Okay, you may use duality properties of electron, or it can behave. Electron can behave as particle and also wave. Okay. Alright, so that would be the de Broglie hypothesis. Okay, next we have Schrodinger. Okay, Schrodinger equation generates a wave function that describes how the electrons are distributed in space. Okay, so this is the wave function. So this wave function describes how the electrons are distributed in space. Okay, so electron, okay, so as of now we know that electron is not circulating the nucleus, okay, in an orbit. Okay, so that is totally, yeah, that was totally rejected last time. Okay, alright, so dia tak mengelilingi the nucleus. So actually it is distributed in space. Okay, so we have nucleus and then we have electron. So the location of electron is not known, tak tahu pun. But we know that it is distributed outside of the region of the nucleus, di luar nucleus. Okay, so those space is is what we call wave function lah, represent the wave function. Okay, so a one electron wave function is called an orbital. Okay, so this is the most important part of quantum number. Okay, the introduction to orbital. So orbit and orbital may sound the same, but they are two different ataupun two totally different things. Okay, dua benda yang berbeza. Okay, like I said just now, orbit is a circular pathway. Okay, that has fixed radius, but not for orbital. So what is the definition of orbital? Orbital is a region. Dia adalah region in space which is outside the nucleus, where there is a high probability, which is more than 90%, of finding an electron. A region in space which is outside the nucleus, where there is a high probability, which is more than 90%, of finding an electron. Okay, so it's all about probability, because we do not know the exact location of the electron, because electrons keep moving. Dia dah laringan. Okay, dia dah laringan. Lepas tu dia sentiasa bergerak, always on the move. So how do we able to determine the exact location of the electron? So it is impossible. So what we can know is the probability to find the electron. Okay, what we know is the location, the region of where the electron can be found. Right? Okay. So orbital and orbit are two different things. So when we are talking about electron, we are talking about orbital, not orbit. No, tak ada lagi yang orbit pusing-pusing tu lagi Okay. Alright, so this is our real deal for topic 2. Okay. So this is the method that we use to locate an electron, to predict. Okay, more on the prediction, to predict the location of the electron in an atom. So we use quantum number in order to determine the coordinate of electron. Okay. Alright, so electron in an atom are not all located at the same distance from nucleus, like what orbit behave. Okay, so that is for orbit. So basically kalau orbit, this is the nucleus kan. So let's say this is the energy level, n is equal to 1. Okay, kalau orbit maksudnya the electron is circulating. Okay, so this would be the radius, the fixed radius. So we will be able to know the electron punya position. But if it is an orbital, so this is the nucleus. Okay, this is the nucleus. This is the energy level. So the electron, the orbital means the probability of finding an electron. So this is the location that electron may be present. Okay, so dia ada dekat kawasan ni. Dia sentiasa bergerak kan. So we plot dekat kawasan ni. Oh, the electron density is very high here. Okay. So that will be the orbital lah. Bukan bermakna ada banyak elektron kat situ tau. Katakanlah hydrogen, for hydrogen kan. So there is one electron for hydrogen. But dia duduk, kawasan dia duduk tu di mana-mana. As long as dia dalam region, this region. Okay. So that is what we call orbital. Okay. So the quantum mechanical model describes the energy level of the electron in orbital. So we have the energy level, same as what we have in Bohr's postulate. Okay, so energy level is still applicable. So the electron located in specified space from nucleus, which is energy limited to discrete values. So discrete is also known as quantized. Okay, so it is located in specified space. Space yang tertentu, okay, from the nucleus, which the energy is limited to discrete value. So each electron is characterized with a set of quantum number. This is like the coordinate of electron. So we need to know these 4 quantum numbers. Okay, so these 4 quantum number is considered as one set of quantum number. Okay, so one set of quantum numbers should consist of 4 quantum numbers. So we have principal quantum numbers that we can use n to represent this. and we have angular momentum quantum number, which is in short we can use L for that. And then we have magnetic quantum number, ML, electron spin quantum number, SMS. Okay, all right. So this is very important. You please make sure that you really understand this, how to determine the quantum number and how it is being assigned. If not, later on you will have problem lah in understanding the next subtopic. So it all depends on this quantum number. Okay, so remember, quantum number is used to locate an electron. Okay, for example, awak nak locate saya kan, you should know, awak nak tahu saya di mana. Okay, saya at the moment, where is my home, for example. Okay, madam duduk dekat mana. Okay, what you should know is, madam duduk dekat Malaysia ke kat England. Okay, and then what else? The negeri, the state that madam is in, Selangor. And then next, maybe the city, Dengkil. Okay, as you can see, dia makin lama dia narrow down until you finally find me. Okay, jumpa saya. Sama juga for electron. Okay, in order to locate electron, kita tak pakailah negeri, city, nombor jalan, nombor rumah tu. Okay, but we can use that analogy in order to understand what the purpose of having quantum number. Okay, all right. So we are going to go each one of the quantum number. Okay, so please make sure that you really understand what quantum number is for each one of them. Okay, all right. Bismillahirrahmanirrahim. So let's start with principal quantum number n. Okay, all right. Before that, lupa nak tanya soalan. Do you have any question related to the previous slides that we have earlier, guys? So far.
No.
So far, are you doing good there? How are you doing?
Yes.
Yes.
Okay. All right. So based on that response and feedback, okay, I shall continue. Okay. Principal quantum number n. Okay. So principal quantum number n represent the principal energy level of a specific electron that is also known as shell. Okay, so energy level / shell, okay, both can also be used. So what is the function ataupun what is the purpose of principal energy level ataupun the energy level itself? So it shows that the distance of electron from the nucleus. So this will be the furthest, okay, that electron can be away from the nucleus. Macam ni lah contoh, we have nucleus here. Kata ini this is nucleus kan. This is N1 for example, and then we have N2 and so on kan. So this is N1, this is N2. So this is what we call principal quantum number or shell. Okay, this is like the boundaries. Dia punya kawasan tu. Contohnya madam kena ada dekat Selangor. Selangor lah boundary saya. Janganlah pergi cari kat Johor pula. Okay, so same goes to electron. So we can locate this electron at n is equal to 1. Okay, at n is equal to 2. So the boundaries ataupun the furthest, the principal quantum number represent the furthest that the electron can be away from the nucleus, the distance lah. Okay, so dia boleh ada dekat dalam ni, boleh ada, tapi the furthest dia boleh untuk n is equal to 1 should be this, kat sini. Okay, so that will be n is equal to 1. So shell, okay, shell is identified by the letters K, L, M, and O, and so on. And then we can also assign a form of positive integer. Okay, look at the boxes that we have here, the table. So we have principal quantum number n, principal quantum number or n, okay, and we can assign the letters for each one of them. Let's say if n is equal to 1, that means it's a K. Okay, if n is equal to 2, that means the shell is an L shell. Okay, so it start with K but not A. Jangan pandai-pandai Nombor 1 dan A, nombor 2 B. Okay, salah. Dia ada nama dia kat sini. Dia punya representation, the history how this letter was assigned, tapi saya tak ingat. Okay, if you want to know more, okay, you want to know further about this, you may read from the textbook or maybe from the internet. Okay, so 1, 2, 3, 4. So it should be all positive integers. So make sure that you know that if n is equal to 1, that means it can also be known as K shell, L shell, M shell, N shell, and O shell. So it depends on the question lah. Okay, if the question give out information in the form of letters for the principal quantum number, then you should know. For example, determine the number of electron in N shell. Okay, for N shell, that means you should know that the N for N shell is equal to 4. The N for M shell is N is equal to 3. Okay, you should know vice versa lah. Okay, jangan tahu numbering je, tapi the letters tu tak tahu. Okay, so N is correlated with the orbital size. Like I said just now, this is the furthest, so this also represent the size of the orbital. So as N increases, the energy of the electron in the orbital also increases, the size of orbital increases. So when the number of N increases, so katalah N sama dengan 1, N sama dengan 2, N 3. So as you can see, the number of N increases. When the number of N increases, that means the energy, okay, the energy also increases because it is now further away from the nucleus, further away from the nucleus. So by right, the energy is also increases, and of course the size also increases. Okay. Right, so this is how we can represent the N. Okay, so N is equal to 1, 2, 3, and 4. For example, so this is how the orbitals looks like. Okay, just focus on the number. Okay, so ini kita akan put on hold first. Later kita akan go for why is it S. Okay, we have other types of orbital also. Okay, that one will be covered later in the slide. Okay, just focus on the value, the number, the positive integer here. So this is how the N is equal to 1 looks like. As you can see, if N is equal to 2, it gets larger, and N is equal to 3, it is even larger. Okay, it is even larger. So that is this is just to highlight the energy level, maksudnya the distance, okay, of the orbital from the nucleus. Okay. Sorry. Okay, how are you guys doing for principal quantum number N? So far so good?
Yeah, so far so good.
Alright, okay. Okay, alright. Principal quantum number is not a problem. Okay, maybe kita akan, next will be the L lah. The L, ML, and these two can be quite, taklah tricky, tak ada tricky pun. Tapi you just kena faham, okay? Next will be angular momentum quantum number, or in short, we can write it as L. Okay, L, or we can use this L to represent the L, the angular momentum quantum number. Okay, so what does this L represent? Okay, ingat tadi, N for N just now, that the N represent the distance of the orbital from the nucleus. Okay, the energy level, the boundaries. If N is equal to 1, that means we have this distance. Okay, the furthest, paling jauh, the orbital can be from the nucleus. And then L, how about L? L represent the shape of the orbital. The shape of the orbital. So orbital itself has its own shape. Okay, all right. Orbitals with the same values of N may have different shape which are designated as below. Okay, they may have the same value of N but with different shapes. Okay, alright. So value of L, for example, again kita ada 4. Tadi tu we may have more, tapi normally N sama dengan what do we have just now? So 5 lah. Boleh ada, we can have more than 5, but normally kita sampai 5 lah, 5 or 6 lah macam tu Normally the question. Okay, for L, value of L, okay, it depends on the value of L. So for if L is equal to 0, okay, that means the orbital is S orbital. If L is equal to 1, okay, the orbital is called P orbital, P-shaped orbital, okay. If L is equal to 2, that means it is a D orbital, and if L is equal to 3, it is an F orbital. Okay, all right. So we are going to cover most of the question. We'll cover up until, we may have until F. You should know that we have F orbital, but normally, okay, question highlight ataupun normally we use elements that have D orbital and SPD lah. So this is a common orbitals can be found in elements. Okay, right. The angular momentum quantum number divides the shell into subshell. Okay, so earlier, okay, for the N just now, it is called shell. Okay, it is called shell. But for L, it is called subshell. So in the shell, we have another, we have apa nama tu, subshell. Okay, so that will be L lah. That will be L. Okay, so how do we determine the value of L? Dia ada syarat dia that we should know. Okay, so the value of L we can be determined, okay, based on what we have here from 0 to n minus 1. Okay, so it should be positive integers. So dia punya syarat dia, it depends, as you can see, it depends on the number of n. Okay, take for example, if we have n is equal to 2, for example, then the L should be 0, 1, 0, 1. Okay, because it should be less than nitrogen, less 1 than the nitrogen pula, less 1 than the principal quantum number, or n. It should be less 1 than the principal quantum number. So it should start from 0 until 1 less than the principal quantum number. So it should be 0 and 1. So 2 is not included lah, sebab dia mesti n minus 1, until n minus 1. Okay, so if L is equal to 0, that means this is an S orbital. If L is equal to 1, that means it is a P orbital. Okay, all right. Let's try if n is equal to 1. Then what will be the value of L, guys?
0.
Yes, that's good. Okay, the value should only be 0. So if n is equal to 1, there is only an S orbital. There's no P orbital, D or F orbital. So there is only S orbital. Okay, if n is equal to 2 just now, we have two types orbitals. So we have S orbital and P orbital. So how do you know? So based on this number. So that's why you should know. Okay, the letters, the designation, the letter designation, and also the value of the orbital itself. Okay, right. So maybe we can try out another n. N is equal to 4 maybe. Okay, so the L should be, guys,
3, 2, 1,
3, 2, 1, 0.
sorry.
3, 2, 1, 0.
Oh, start daripada 3 Orang kena start daripada 0. From 0 to n minus 1. So it should be 0, 1, 2, 3. Okay? Okay, dia kena start from 0. So 0 is S. 1 is P. 2 is D. 3 is F. Okay, the reason it should start from 0 sebenarnya, because the higher the value of L, the higher its energy level. So S has the lowest energy compared to P, D, and F. So by right, F has the highest energy, okay, in terms of energy. Okay, so that's why S, P, D, F. F is the highest lah. Okay. So this is an additional slide that I have added in. Sebab we don't have this slide. Tapi sebenarnya the reason that we don't have this slide is because later on, we will again talk about this. Okay, but I feel that you should be introduced to the shape of the orbital. Okay, dia tunjuk kemudian. So nanti takut you you cannot imagine. So that is why, because we are talking about the shape of orbital kan. So what do orbitals looks like? So far we have 4 orbitals, S, P, D and F. So S orbital, so the shape is spherical, bulat. Maksudnya the electron can be found in this spherical shape. So this is an S orbital, shape dia bulat. Okay, as for P orbital, okay, it is in lobe form ataupun cuping. Okay, ataupun what we call that cuping, lobes lah. Okay, dumbbell shape, yes, dumbbell shape. Okay, dumbbell shape or lobe. That would be for P lah. Okay, so this is just to highlight the shape. So this is spherical, this is lobe. As you can see, for P orbital we have 2 lobes. Okay, alright. So kenapa? Maybe you are wondering why this P orbital has 3. Okay, this one kita akan we have another quantum number that would explain that. Okay, so this is just to highlight the shape, how it is look like. Okay, so ni ada 2 cuping. Untuk D, dia ada 4 lobes, ada 4 cuping. Okay, nampak tak? Dia ada 4 cuping, depending on ni lah, ada banyak lah. Tapi ni nak highlightkan again, this is bulat, this is cuping 2 ni, P, and then this is D orbital. Okay, and then dia ada one special orbital kat sini, dia ada dua je, tapi we have ring at the center. Okay, so kenapa dia ada banyak ni later kita tengok on for the next quantum number. And then this is F. Okay, this is how F looks like. So F has even more lobes on it. Okay, so inilah shape dia. Okay. Right. So angular momentum quantum number L. So we have shell. Okay, kita start from N just now. So K, L, M, N, and then to represent this shell, we can the value of N is equal to, if it's K, that means it's equal to 1. If it's L, that means it's equal to 2, and so on. Okay, right. So how about the L? Okay, so L, we know that the formula is for L, in order to determine L, it should be 0 until, okay, maybe boleh tambah kat sini, takut you guys confused. It should be 0 until N minus 1. Okay, alright, so if N is equal to 1, that means the L should only be 0, which is the S orbital. Okay, if N is equal to 2, which is the L shell, that means we have 0 and 1. So this is S, this is P. If N is equal to 3, that means we have 0, 1, 2. This is S, this is P, this is D. Okay, if N is equal to 4, we can have S orbital, P orbital, D orbital, and F orbital. Okay, all right. So how do we represent this subshell? Okay, so we have L. Okay, so this is the representation of L. But to represent the shell and also the subshell, so we have this notation. Okay, so from this notation, we will be able to know the N and also the L. Okay, where the electrons, the location of the electron. So 1s, it should be macam ni So this is the notation. So it should be N and then this is L. Okay, NL. So from this subshell, we have the information that 1s means N is equal to 1. S means it is the electron is in S or B orbital, which is in spherical shape tadi. Okay, so that is subshell notation. Like how do you the nuclear notation of the elements in the periodic table last time. Okay, we have symbol, we have the mass number, and at the bottom we have the proton number. So that is what we call nuclear notation, kan? So for subshell, we have a notation to represent the subshell. So kita guna 1s. 1s means the n is equal to 1. S means the orbital is an s orbital. Okay. Right. Same goes to this subshell if n is equal to 2. So we have s and p, right? So it should be 2s and 2p. Okay. If n is equal to 3, so we have s, p, and d, right? So the subshell should be 3s, 3p, 3d. Okay. So kalau kita ada s, p je, we may wonder, okay, this s belongs to n, what value of n? And which n? Belongs to which n? Dia boleh ada dekat n is equal to 2, 3, 4 and so on, kan? So if we specify the n here, so automatically we know that the n must be equal to 3, n equal to 3. Okay, so the four, so we have S, P, D, and F. So this is how the subshell should be written. So we have 4S, 4P, 4D, and 4F. Okay? Alright, so far okay ke for the angular momentum quantum number before we move to the next quantum number? Okay, because they are related to each other. Right? Okay. Okay ke? How are you guys doing so far?
Okay.
Okay.
Right, okay, good, Okay, next. This is just to show you on how the quantum number is being assigned. Okay, later on, we are going to apply this quantum number. Okay, remember, we have so many elements in the periodic table. So each element has its own electron. So how do we assign the coordinate of the electron? For example, for sodium, okay, sodium has 11, is it? Tak sure, check balik kejap. 11, tak ada pula kat sini. Yes, okay. Sodium has 11 electron. Sodium atom has 11 electron. So how do we assign the coordinate of each electron, of all the 11 electron in the sodium atom? So we are going to be using this quantum number. Okay, ini baru nak belajar on how to assign quantum number. Later, we have the electron. So you should be assigning the quantum number for each of the electron. Okay, alright. That's why important, kena betul-betul fahamkan. So next will be magnetic quantum number. We can use M and then subscript L. Okay. Okay, so magnetic quantum number, as you can see L, so we have L here, so L may depends on the value of L just now. Okay, the value of subshell or the value of, just now we have angular quantum number, right? Okay, it depends on the angular quantum number. Okay, so what is the purpose of having magnetic quantum number? Because it determines the orientation of the orbital. The orientation. So just now we may have known about the shape of the orbital. Okay, we know that the S orbital is in spherical shape, and then the P orbital has two lobes. Okay, two lobes. But as you can see, nampak tak dekat sini tadi? Kenapa? You may have wondered why for P orbital we have 3 orbitals. So 1, 2, 3. Okay, so as you can see from the figure here, okay, they have the same number of lobe. Cuping dia sama, but they differ in terms of orientation. Okay, so for that orientation, we have ML to cater. Okay, we have ML to explain about the orientation. Okay, so this ML represent the number of orbital diagram to be drawn in a respective subshell. Okay, all right. So to simplify the orbitals, okay, like what we have just now. So takkan takkanlah every time we need to draw the shape of the orbital kan. So we may use orbital diagram, okay, to represent the shape of the orbital just now. Okay, we use boxes. Okay, so boxes macam ni, sorry, nanti kita akan nampak lah, kejap lagi kita tunjuk. So these boxes to represent the p orbital. So as you can see just now we have three orientation of p orbital kan. So these tiga orbitals we can represent it using boxes. Okay, so later kita akan tunjuk contoh dia lah. So the value correlates with the number of preferred axes. Okay, so we have X, Y, and Z. So we are talking about orientation, right? So to represent orientation, so by right, we should have axes to represent them, okay, in a particular orbital. Okay, itu we are done with that. Now, how do we determine the ML? Apa syarat-syarat to determine ML? Like what we had in L just now. Okay, alright. So it can be any positive and negative integers between, yep, this one. This is the rule. Okay, it depends on the value of L. So to determine ML, the rule should be from negative L to positive L. Okay, so ML can be 0, plus minus 1, plus minus 2, and so on, because it depends on the value of L. Okay, all right. For example, okay, this is what I meant by orientation. This is what orientation lah. Okay, so we have X orientation because this the shape or the orbital itself is is on the X axis. Okay, so this is Y axis, this is Z axis, this is between X and Y. So the orientations are all different. Nampak tak? Shape sama, tapi orientation berbeza. That will be ML. This is ML. Okay? Alright. So, based on the rule that we have here, let me clear everything off first. Okay. Let's say if we have n is equal to 2. If n is equal to 2, let's start from the beginning, okay? N is equal to 2. That means the L should be, we have 2L, right? So 0 and 1, right? Okay, so for the ML, so what, which one should we go for? That is not the case, You have to go for each L. So for the ML, we know that the syarat should be negative L, 0 until positive L. Okay, all right. So let's have ML for 0 first. Okay, so the ML for 0 is, guys, what would be the ML for 0?
-1, 0, 1.
Okay. It depends on the L, right? So if the L is equal to 0,
0.
yeah, macam mana
Zero.
boleh -1, 0, 1? So it depends on the L, it depends on the L. So since L is equal to 0, that means takkanlah kita ada negative 0 until positive 0 kan? So it should be 0 lah. Okay? So, and then we are done with L. The ML for L is equal to 0. Okay, next will be the ML for L. The ML for L is equal to 1. Okay, so the ML should be
Plus minus 1.
Plus minus
jangan sebut plus minus 1 macam tu. Kena sebut
Positive
negative 1, 0, positive 1. Okay? So negative 1, 0, positive 1. This represent the orientation. Okay, the orientation. Okay. That is n is equal to 2. Kejap lagi kita akan go detail on how the orientation of the orbitals looks like. But this is just to test out lah. You faham ke tak faham? Okay, based on the syarat that we have here. Okay, let's try n is equal to 4. Okay, if n is equal to 4, that means L is equal to
0, 1, 2, 3.
1, 2, 3, 4.
Belajar. Sorry. 0. Jarak sikit. 1. Right sikit.
2, 3.
3. Ada 4 ke?
Tak ada.
Two, madam.
Apa dah lah macam pendek pula 2, 3. Okay, alright. So then next will be ML. Okay, for ML, do not choose. You have to to list all the ML for that particular L, unless question has specified. Okay, for any of the L given lah. Tapi kalau ini in general, you should list out all the ML for each L. Okay, now let's go for L is equal to 0 first. What will be the ML for 0?
0.
0. Yes. Okay, don't forget, okay, this is S orbital, this is P orbital, this is D orbital, and this is F orbital. Tu kena ingat. Okay, because subshell notation is very important. So ni nanti dia akan jadi for S orbital, this is for P orbital, this is for D orbital, and this is for F orbital. This is what we call subshell notation. Okay, alright, so for ML, ML for L is equal to 1, then it will be
Negative 1,
Positive 1,
0, and 1.
yes. Okay, alright, so this is for P orbital. Okay, how about D orbital or L is equal to 2? Buat kat bawah lah okay. What will be the values for ML for L is equal to 2, guys?
-2, -1, 0, +1, +2.
Yes, very good. Okay, so it should be -2, -1, 0, +1, +2. Okay, alright. So same goes to N is equal to bukan N. L is equal to 3. Then we're gonna start from N. ML is equal to -3, -2, -1, 0, 1, 2, 3. Okay. So kalau itu dah okay, maksudnya dah pandai lah tu. Alright. So now let's move on to the next slide. Okay. Alright, correlation between L. Like I said just now, okay, so we have L, it represent the orbital shape. So the ML on the other hand represent the electron orientation. Okay, ini kita dah sampai dekat bilik elektron lah. Bilik elektron ada bilik so kita dah sampai yang quantum number 3. Quantum number 3, which is the magnetic quantum number. Alright, so L is equal to 0. We know that it is an S orbital, so we know that S orbital is spherical in shape. Okay, alright, so the ML, we know that it is 0. So this 0, saya boleh analogikan dia as the room number of electron. Okay, alright, so ML is equal to 0. That means this S orbital has one orbital, S shape. Okay, kalau saya nak cakap S shape orbital has one orbital sahaja. Tu mungkin agak confusing kat situ. Tapi maybe for P nanti you can see clearly. Okay, alright. So we have one orbital because this ML is equal to 0 is the it represent the number of orbital present for that particular orbital. Faham ke tu? Okay, alright. So to represent this, kita guna this orbital diagram. So this is what we call orbital diagram. So for S orbital, we only have one orbital sahaja. Okay, like P just now we have 3 orbitals kan? For S orbital, we only have one orbital. Okay, one orbital saja. We know that dia spherical kan? So either way pun buat macam mana shape dia tu, X axis, Y axis or Z axis, there will be no different lah. Okay, dia tak ada orientation dia sama je. So that's why there is only one orbital for S shape orbital. Okay, so kalau saya nak represent dia, bilik dia ni nombor dia 0. So this is ML. Okay, so there is one orbital, there is one room for S shape orbital. So dekat sini dalam ni where the electron can be located. There is only one orbital for S-shaped orbital. Okay, alright. So mungkin agak blur kat situ. Okay, maybe we can look for P orbital here. Okay, so P orbital, So L is equal to 1 is p orbitals. Okay, so the shape can be known as dumbbell-like shape. Okay, dumbbell-like shape. Dia macam dumbbell kan, ataupun lobe tadi, cuping tadi. Okay, so if L is equal to 1, that means the ML should equal to -1, 0, plus 1. So this represent the orientation kan. So the orientation also represent the number of orbital. Okay, the number of orbital that the electron can be located in. Okay, so this one, -1, 0, 1 is the numbering. Tapi if kalau kita based on the orientation, it can be in the form of Px, Py, Pz. Or I can simply assign this is -1, this is 0, this is +1. Okay, alright. So this is important because it helps us to simplify the orbital sebab tak letih jugalah every time kita nak kena lukis orbital shape ni macam ni kan. Kalau setiap kali nak buat orbital nak kena draw macam tu. Okay, alright. So by having this ML, we can use this value -1, 0, 1 to represent to use the boxes. Okay, to represent the orbital. So this would be our -1, 0, 1. Okay. -1, 0, 1. So as you can see, we have 3 orbitals because we have 3 orientation for p orbital. Okay, we can also use px, py, pz or -1, 0, 1. So normally for ML we use the number lah, numbering -1, 0, 1. So this is for drawing sake, maksudnya kita nak draw based on the orientation ataupun based on the axis. Okay, alright. So p orbitals, p maybe saya boleh highlight p shape orbitals. Okay, has 3 orbitals ataupun 3 orientations of orbitals. Okay, right. Same goes to d orbital. Okay, so as you know, d orbitals has 4 lobes, ada 4 cuping tu. Okay, so if L is equal to 2, that means it's a d orbital, or it can also be known as clover leaf. Okay, the shape of clover leaf tu yang macam tu kan. So this is how the clover leaf looks like. So it may look the same with the d orbital lah. Okay, closest to the d orbital lah. Okay, so if L is equal to 2, based on the syarat that we have learned just now, the ML should be -L, 0, 0 until +L. Okay, so it is -2, -1, 0, +1, +2. Okay, alright. So this explains why the orientation here, we have 5 orientation for the d orbital. So we can also assign it as dxy ni sebagai what do you call this? -2, -1, 0, 1, 2. Okay, alright. Kalau kita nak draw the boxes ataupun the orbital diagram, so this is what we call orbital diagram. Okay, we can use boxes, kan sometimes even kita nak boleh, we can also simplify in this form. These boxes can also be simplified in this form. 1, 2, 3, 4, 5. Tak payah buat boxes pun. Okay, we may use these dashes, okay, to represent the orbital. So here we have -2, -1, 0, 1, plus 2, +1, +2. Okay, or we can use this as to represent the axis. Okay, so every time pun, yelah, ini quite tricky lah. Sometimes kita boleh miss out. Okay, so let's just use the ML value. Okay, the ML value. So as you can see, we have 5 orbitals. So 5 boxes, 5 rooms for electrons. So there should be 5 orbitals for D-shaped orbitals. Okay, alright. So ni nombor bilik dia, -2, -1, 0, 1, 2. Okay, so far okay ke? Do you have any question related to ML?
Okay, madam, no question.
Okay, no question Ada question tolong tanya bukan saya tak tanya Ni kalau tak faham ketuk kepala ni. Tanya, jangan takut. Alright. Okay, so this is like summary lah, okay? ML depends on the value of L. Okay, if L is equal to 0, that means this L is an S orbital. This is a P orbital. This is a D and this is an F orbital. Okay, so the value of ML for L is equal to 0 or for S-shaped orbital, it is equal to 0. Maksudnya kalau if we were to draw the orbital diagram macam ni. So dia ada satu bilik, nombor bilik dia 0. Okay? Alright, so this is for S orbital. So the type of subshell is S. Okay, so the number of orbital, the number of orbital present for S-shaped orbital is only 1. So dia ada satu bilik saja. And then bilik dia is equal to the room number is 0. For P, the value of ML is -1, 0, 1. So this shows that the P orbitals has 3 orbitals. The P-shaped orbital has 3 orbitals. So this is how the orbital diagrams looks like, -1, 0, 1. So this is what we call P orbitals. So as you can see, we have 3 orbitals, okay, -1, 0, 1. So there are 3 orbitals. Okay, same goes to D and F. So that's why the number of orbital for D is 5 and the number of orbital for F is 7. So this is fixed. Okay, so this is fixed for all of the orbital shape. Okay, so by right you dah boleh terus hafal terus lah. Remember, if S orbital, there should be 1 orbital for S shape orbital. For P orbital, there are 3 orbitals. Okay, for P shape orbital. D orbital should have 5 orbitals. Okay, F shape orbital, there are 7 orbitals for F shape orbital. Okay, all right. So an orbital can hold up to 2 electrons maximum. Okay, like I said just now, ML actually represent the room of electron. Okay, the room of electron, and then the number of room for the electron. Okay, so for one room, for one orbital, it can only accommodate 2 electrons at one time. That's all. Okay, it cannot be more. So it can be 2 maximum, it can also be 1 or it can also be 0. But maximum should be 2. So this is the nilah. Okay, it should not be more than 2 because you know electron, they have the same charges. Okay, they have the same charges. So by right, same charges should be repelling. Okay, so there is repulsion between them. So the more electron in the orbital, that means they will have higher repulsion. So the maximum that they can tolerate is 2 electrons at one time. Okay, all right. So we have that information already. So for one orbital, we can only accommodate 2 electrons. Okay, so number of electrons in each energy level can be determined by, okay, katakanlah the question, the question is asking for the number of electron with for the given n is equal to 2. Okay, for n is equal to 2, how many electron can be placed in n is equal to 2? Okay, so how do we do that? Okay, in order to know the number of electron, we should know the number of orbital we have in the n. And for n is equal to 2. Okay, alright. So in order to do that, kita kena go from the beginning lah. Kita kena start from the beginning. So n is equal to 2. L, for L we have ni kan. Patutnya kita kena kosong dulu lah. Jadi kena switch the other side. Okay, we're gonna start with 0 first lah. Okay, tapi based on what we have here, Tak nak, saya nak buat juga dekat sini Okay, so L is equal to 0. Okay, and then L is also equal to 1. So for N is equal to 2, we have S orbital and also P orbital. Okay, for ML, L is equal to 0, we have 0, right? For L is equal to 1, we have ML is equal to -1, 0, +1. Ini ingat balik dia punya rules tu. Negative L, anti-positive L. Okay, so remember this 0 represent the room number. Okay, as if dia macam ni. Dia ada satu bilik. Satu bilik means one orbital lah. S-shaped orbital has one orbital. So the room number is 0. So this subshell can be written as this tau. Saya tambah information this information. So with this 2S. It should be 2S. Not sure whether you guys can boleh nampak ke tak 2S. So this is a 2S orbital. How do we know that this is a 2S orbital? Because the N is equal to 2. And we are talking about S orbital kan? L is equal to 0. So that's why the subshell can be written, the notation can be written as 2S. Okay, so there is only one orbital there. And for ML, we have -1, 0, +1. Okay, all right. So if I were to draw the orbital diagram, so 1, 2, 3. So this is the room number, -1, 0, 1. Okay, so the subshell can be written, the subshell notation can be written as, apa dia? Guys, the subshell notation, if this one we have 2S, how about this one? Anyone? What would be the subshell notation for this one? If this one is 2S, how about this one?
2p.
Yes, it should be 2p lah. Okay, this whole thing is 2p orbital. Okay, dia located kat N sama dengan 2 and then these tiga orbital ni belong to P orbital. Okay, so this is 2S. This is 2p and then if we have d orbital, kita ada 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, sorry. Okay, then d orbital dia start dengan sama dengan n sama dengan 3 dia tak ada dekat n sama dengan 2 Okay, because n sama dengan 3 then only we can have L is equal to 2. Less than that we don't have L is equal to 2. Okay, alright. So that's why d orbital is present at for n is equal to 2, n is equal to 3. So kita boleh tulis macam ini. 3d orbital. So this is -2, -1, 0, 1, 2. Okay, alright. So this is how you can draw the orbital diagram. You can represent the orbital diagram or the room for the electron. Okay, alright. So each orbital can accommodate 2 electrons. So this is how it looks like. Satu orbital boleh accommodate 2 elektron. Okay, so nampak tak? Kita ada 3 orbital, that means 2, 2, 2 lah. So how many electrons are there if n is equal to 2? So we have to total up. So here we have 6 electron and here we have 2 electron. So 6 plus 2 would be 8. Okay, would be 8 electron. Or you can also count ataupun determine the number of orbital and then just multiply it with 2. Okay, so we have 4 orbitals, right? So we have 3 orbitals for P and then 1 orbital for S. Okay, for S orbital. So 3 plus 1 will be 4. There are 4 orbitals, so we times with 2 because for 1 orbital there should be 2 electron present. So that's why 4 times 2 is equal to 8 electron. Okay? Alright. Okay, right. So we are done for the ML. Last but not least is the electron spin quantum number, which is the MS. Okay, this MS represent the electron itself. Kan kita nak locate the electron kan? So this MS represent the electron itself. Okay, the properties of the electron itself. Okay, So all electron have a property called spin. Spin tu maksudnya dia punya apa nama the way dia spin lah, dia pusing kan, dia bergerak. Okay, the electron can only spin. Okay, dia tak boleh melompat ke apa kan, dia can only spin. So the how the electron spin, okay, there are two ways to for the electron to spin ataupun to move. Okay, so it can either spin clockwise or anti-clockwise, okay, in a magnetic field. So this is our electron, okay, this is electron. So it can spin clockwise or anti-clockwise. That's all. That's for MS. Kita tak ada, MS is independent, okay, MS will not depends on L, N or ML, any of these three. Okay, neither these three, dia tak represent, it's not directly related to the MS. Okay, they stand alone. Okay, so because we know that in orbital there should be two electron kan just now kan. Okay, for example we have one s orbital just now yang bilik dia tu kosong tu. So by right there are two electrons in one orbital. So one should be pointing up. Okay, so this is how you represent the electron. So we use arrow, okay? Kita tak tulislah E macam tu. Tak. Kita represent electron by using arrow. And in fact, it should be half-headed arrow. So betulkan yang ini? Okay, betulkan this arrow. So it should be half-headed arrow. So one should be pointing up. Okay, the other one should be pointing down. So this is clockwise and this is anti-clockwise. Pointing down should be the anti-clockwise. Okay, all right. So in one orbital there should be two electrons, right? So one should be pointing up, the other one should be pointing down. So it cannot be represented as this, tak boleh. Okay, ni tak boleh because if both of them are having the same spin ataupun both of them are pointing up, okay, that means the repulsion would be higher. Okay, so this is one of the way to reduce repulsion. So one should be spinning clockwise, the other one should be spinning anti-clockwise. Okay, so we use arrow ke atas positive half. Okay, downward is negative half. This one, that's all. MS. Okay, for MS we have positive half for clockwise ataupun pointing up, upward position. Downward position should be negative half. Okay, so we have positive half and negative half. That's all. Okay, tu dah habis lah MS tu. Tu kita dah tahu dah dalam bilik elektron tu ada berapa elektron duduk dekat dalam bilik elektron tu. Okay, so these are the summary. Okay, that you may refer to. So N will be the positive integers. Maybe you can add in. It can also be assigned with shell ke. Okay, so you can add in that information. Okay, this is just for your reference. Okay, alright. Sama lah macam yang tadi tu kan. Okay, if kalau kita start from the beginning, okay, if N is equal to 1, then the L should be 0, betul tak? Then the ML for this L will be 0 lah. Okay, ni bilik dia 0. So N is equal to there is one orbital. So the type of orbital, so this is what we call 1s orbital. How do we know so? Because the L is 0, 0 means S, betul tak? And then this value come from N. So N is 1. So that's why they're 1s orbital. Okay, so the maximum number of electron that can accommodate this orbital is 2. So total number of electron, if N is equal to 1, that means it should be 2 lah. Okay, sebab we do not have other orbital for N is equal to 1. Faham tak? Kita hanya ada L is equal to 0 sahaja, which is S orbital. We do not have P, we do not have D and F. So that's why N is equal to 1 must only have S orbital saja. But if N is equal to 2, that means we have 0 and 1. Okay, ni syarat dia apa? Awal-awal itu 0 until N tolak 1. ML pula negative L Okay, 0 until positive L. Okay, alright, so we have 0. So for 0, the ML is 0. Maksudnya dia ada S orbital, so bilik dia, so this is 1s. So if, and we also have an L is equal to 1. Okay, 1, 2, 3. Negative 1, 0, 1. So this is 2p orbital. Okay, so this explains why at n is equal to 2, there are only there's only s orbital and p orbital. There's no d orbital. Kan saya cakap tadi, n sama dengan 2, tidak ada d orbital because the L is only equal to 0 and 1. Okay, in order to have d orbital, we need L is equal to 2. Kalau L is equal to 2, dia tak boleh lah, dia tak tally dengan syarat dia ni, syarat this one. So it's not allowed. So if n is equal to 2, there should be s orbital and p orbital only. Okay, so that's why we have 2s and 2p orbital. So for 2s orbital, we only have one orbital saja kan. So there should be 2 electron and then 6 electron for for p orbital. So we total these two, we got 8. Okay, and so on lah. So n is equal to 3, then only we can have the d orbital. Because n is equal to 3, we have 0, 1, and 2. So this is S, this is P, and this is D. Okay, based on what we have here. Ni syarat dia ni. So these are the orbital lah. So this basically represent the orbital. So this is 1 orbital, this is, we have 3 orbitals. So here we have 5 orbital. Okay, so 5 orbitals. So to determine the number of electron, just time with 2 lah. Everything times with 2. So we got 18. 2, 6, 10, 18. So this is the type of orbital, the notation of the orbital. Okay, 3s, 3p, 3d. And same goes to this one. All right, okay, I give you maybe 2 minutes. Okay, for you to complete this question, two and a half. Okay, try out this question first, and then we will discuss based on what you have understood from my lecture just now. Okay, cuba try. Okay, cuba try on your own. For n is equal to 3. Cuba kadang tak tahu nak start from where ni. How do I start? Terlalu banyak sangat information. Okay, cuba. Okay, tenang, try. Okay, all right. So what do you get for this question? What is the answer? Determine the total number of orbital for n is equal to 3.
18 electron.
Read the question carefully. Okay. Determine the total number of orbital.
9.
Yeah.
9.
9.
Okay, good. But you can extend it further. okay, saja nak practice, okay, try to determine the number of electron. Okay, whatever it is, make sure that you address the question first. Okay, address the question first because that will be your marks kat situ. Okay, so there should be 9 electrons and 18. So how do you determine that? So n is equal to 3, then the L should be 0, 1, 2. Okay, and then for the ML, for 0, it should be 0 lah. Okay, for ML, L is equal to 1, it will be -1, 0, +1. This is -2, -1, 0, 1, 2. So this is S orbital, this is P orbital, and this is D orbital, SPD. Okay, alright. So this ML actually represent the number of orbital itself. So we have one orbital. Okay, ni dia punya bilik lah, kosong. Okay, bilik dia, nombor bilik dia, satu orbital. So we have one orbital for S orbital. Okay, S-shaped orbital. For P orbital, we have 3 orbitals. Okay, for D orbital, we have 5. D-shaped orbital, we have 5 orbitals. If we were to draw the orbital diagram, then this is how it should looks like. Okay, so this is what we call 3s orbital. Practice. Okay, yang mana you boleh practice. So this is a subshell notation. Okay, this is the room number. Okay, so kalau full, that means we have 2 electrons. So for the P-shaped orbital, 1, 2, 3. This is -1, 0, 1. Okay, so the subshell notation would be 3p. Okay, 3p. Okay, if all of the orbitals are fully occupied, that means dia akan penuh. Okay, you may have noticed that, nampak tak cara saya letakkan elektron tu? Okay, later kita akan cover that. Okay, alright. So this one 5 orbitals. Okay, this is -2, -1, 0, 1, 2. So the subshell notation for all of these 5 orbital is 3d. Okay, if all of the orbitals are fully occupied, that means dia akan jadi 5 times 2 will be 10 lah. Okay, so there are 10. So 10 plus 6 plus 2. So it will be equal to number of electron is equal to 80. Okay, you can total that or you can go for the number of orbital. So we have 9. Okay, jawab dulu soalan number of orbital, we have 9. So for electron number, we can simply just minus with 2. Okay, jangan buat kat sini, buat dekat bawah. Okay, 9 times 2. Okay, so ini jawapan akhir. You kena, jangan 9 darab 2 macam tu. Your final answer, okay, for this question will be number of orbital 9. This is just extra for you to practice. So number of electron will be 9 times 2. Okay. Alright, so dia menarik kalau you faham. It is very interesting for you to know, okay, and to apply later on. Okay, so we have other. So this is the answer lah. So dia nampak tak? 3S, 3P, 3D. Okay, so samalah. Ni totalkan approach tu. Okay, alright. So we have a few other checkpoints. So you may write your apa nama tu? You may try it out first and then we will discuss it